Alright guys, welcome back with optics. Today we're doing like an introductory lesson on mirrors and reflection. We're just talking about plane mirrors. So here we go. Reflection, law of reflection. Okay, law of reflection, the angle of incidence is equal to the angle of reflection. Okay, so what does that mean? So what that means is if we have a person here and they're looking at it, that means it's going to make this angle. So let's say if this was coming in at 30 degrees, the angle of reflection where you would see the person would also be at this 30-degree angle. Okay, see yourself. So wherever the ray is coming from, it's going to make an exact angle of the angle it came in at. Okay. Both angles are measured from the normal. So this is the normal. Okay. A perpendicular line to the surface. The incident ray strikes the surface at an angle. The reflected ray bounces off the surface at the same angle. So for example, let's say if it was coming in, like a ray was coming in like this, and it made, let's say, a 70-degree angle, it would come out like this, making a 70-degree angle from the normal. Okay, a bit about reflection. Cool video just to show a little bit more of how this works. Highly recommend you watch it. A plane mirror. So a plane mirror, what we mean by that is like a flat mirror. Okay, just the regular old mirrors we're used to. A plane mirror creates an image that appears to be behind the mirror. So what that means is when you're, let's say you're looking at this through this mirror, and there's an object over here. Object. It looks as like you can see this object through the mirror. Like when you look at the mirror, it looks like, oh, it looks like the mirror, the object over here. But that's not real. The real object is over here, and this is just the image. Okay. So this type of image is called virtual image because light does not actually pass through it. So for something, there's a real image and then there's a virtual image. Mirrors are going to have these virtual images. Why that is because if you were to put like a screen here or a piece of paper, there wouldn't be an image that formed here. Okay, there wouldn't be an image that formed here. If in order for it to be a real image an image would have to form where this is supposed to be. But this is just a virtual image. The distance from the object to the mirror is equal to distance from the mirror to the image. So distance of object, distance to image, these are going to be equal to each other. Okay, for these plane mirrors. All right, those are the basic things. How does the image of an object appear when placed in front of a plane mirror? Upright, larger than the object in real. Upright, same as the object in virtual. Inverted, smaller than the object in real. Inverted, larger than the object in virtual. Upright, larger than the object in virtual. So first of all, we should know that it is not inverted. Inverted means that it's upside down. When we're looking at a plane mirror, it's going to be right side up. So upright. It's not going to be larger than the object, so it can't be this. It can't be this. So it has to be this. It's going to be the same size, and it's going to be virtual, meaning not a real. The image is not going to be real. And we'll talk more about virtual images and real images a little bit later on. An object placed in front of a plane mirror, where does the image appear to be in the mirror? So like we talked about last time, the distance of the object is going to be the same as the distance of the image. So in that case, it's going to be C. And that's pretty much it. Pretty simple plane mirrors. Next time we're going to talk about spherical mirrors where things get more complicated. So hope to see you with that. Thanks for watching, everyone. Bye.